Are you looking for a school that nurtures your child's academic, spiritual, and personal growth? Andalusia Academy International School, where your child's future is our priority. We offer comprehensive education levels, kindergarten, Pearson I Primary Certificate, secondary and Pearson IGCSE certificates.
We are a school that emphasizes in the Deen and Dunya. It's integrated in that on the side of Islamic studies, we have Quran, we have Hadith, we have Arabic. And then of course in the secular side, we have all the subjects.
We focus on student-centered learning, where we engage our students in different levels. Other than that, we have very innovative teachers who help to cultivate creative thinking, problem solving, which are very, very key skills in our learners, not only in school, but also for their future.
Hello everyone, my name is Aisha Mohammed and I'm a student under Andalusia International School. I've been here for the past 5 years and I'm in year 11 right now, and my experience in this school so far has been amazing.
Admissions are available. Visit us today. We are located in Nairobi, South Sea, Andalusia Academy International School, where your child's future is our priority.
Hello, my name is Madam Naomi, and this is Andalusia Academy, of course in Horizon TV, and I'm going to teach you physics. And for today, we're going to look at voltage and current in circuits. So, voltage and current in circuits. Okay, so at the end of today's episode, you make sure at least you differentiate between voltage and current. And we're going to start with current. Yeah, we're going to start with current. Okay, when we define current, we simply mean current, this is the flow of charge. Current is the flow of charge. So this is the flow of charge. Yes, under current, what we're going to measure in measuring current, and we're also going to calculate charge under current. So today we're going to look at measuring current. Okay, when we measure current, we're going to look at the device which is used to measure current, and of course the units of measuring current. Okay, we usually use an ammeter when we measure current. So an ammeter measures current. And sometimes you can ask yourself, why do we use an ammeter to measure current? Simply because it has low resistance. We simply use a device which has a very low resistance, so that is not going to tamper with electricity. So an ammeter has low resistance. That's the reason why we use an ammeter to measure current. And an ammeter, this is the symbol for an ammeter. An ammeter. This is the symbol for an ammeter. And of course, I told you we're going to look at the units. Which units do we use to measure current? So current is measured in amperes. Amperes. So current is measured in amperes. This is the spelling of the word amperes. And of course, amperes is written as capital A. This is the symbol for measuring current. So for example, you have current flowing which is 2 amperes. For example, we have current flowing which is 2 amperes. We simply write it 2 amperes. There is no need of writing amperes in full. We understand when you've written 2 amperes. And an ammeter, of course, in a circuit, an ammeter is connected in series. As we move, you're going to understand we have 2 circuit connections. We have parallel and series. So for an ammeter in an electrical circuit, it is connected in series. What do we mean when we say in series? It's connected next to the bulb or any other component which we are measuring current. So how does a series circuit appear when we are measuring current? Using an ammeter, of course. So when we measure current, an ammeter, of course, this is a simple circuit, this one. An ammeter is connected next to our bulb. This is our bulb, and then our ammeter is connected in series with the bulb. Okay, I might have drawn a very simple one. Of course, the current is always flowing in this direction. Don't forget that. It's flowing in this direction. So an ammeter is always connected in series to our component here. And I've told you the component we're using here is the bulb. So after looking at the measuring of current, we're going to calculate the charge. How do we calculate charge? Of course, when we're calculating charge, we're trying to see how much current is flowing in this circuit. So we're going to look at how are we going to calculate charge, calculating charge. Calculating charge. And of course, charge, we simply refer it to quantity of charge. And the symbol of quantity of charge is Q, capital Q. So how do we calculate charge? Of course, charge is calculated by charge is equals to current multiplied by time. Charge is equals to current multiplied by what? By time. And you make sure time is always in seconds. So our time here, time is always in seconds. So if you come across a question which is asking you to get quantity of charge and the time is given in minutes, you make sure you change to what? To seconds. And of course, to remind you, 1 minute is always equals to what? To 60 seconds. So the current is always it always passes through what materials we call conductors. And in conductors, current is usually carried by electrons. Yeah, you know what electrons are. So current is usually carried by what? By electrons. Electrons carry current. That was just a reminder. And another thing, so we're calculating quantity of charge. And the quantity of charge, the units of quantity of charge is in coulombs. So charge, the units of charge, the units of charge. So the units of charge is always in coulombs. Units of charge. The units of charge is always in coulombs. Capital C. Yes, the units of charge is always in coulombs, which is capital C. So I've told you that current is carried by electrons. And you know, one coulomb of charge is carried by so many electrons. In a circuit, one coulomb of charge is carried by 6 multiplied by 10 raised to power 18 electrons. You can imagine this number of electrons carrying only one charge. So we're going down to examples. So examples. We're going to start with example 1. So example 1, calculate the charge flowing. Calculate the charge flowing through. Calculate the charge flowing through a wire of 5 amperes in 10 seconds. So this is a simple question. Calculate the charge flowing through what? Through a wire of 5 amperes in how many seconds? 10 seconds. Of course, you can identify our current is here. Our current is 5 amperes, and time, of course, it is simplified. It is in seconds. So quantity of charge is equals to current multiplied by time. Of course, we have our current here. Our current, which is 5 amperes. You multiply by what? You multiply by our time, which is 10 seconds. You get your answer as 50. And I told you the charge, the unit of charge is always in coulombs, capital C. So this is our answer when you're being told to calculate the charge. And question B, this is part B, part A I mean. Part B of this question, they can ask you, calculate the number of electrons. Like how many electrons are going to carry this amount of charge. So how many electrons can carry this amount of charge? So how many electrons can carry that charge? Yes, so how many electrons? We said one coulomb of charge is not something very small. It's carried by so many electrons. So one coulomb of charge, we said is carried by how many electrons? It's carried by 6 multiplied by 10 raised to power 18 electrons. So if one coulomb is carried by those number of electrons, what about 50 coulombs? So 50 is going to be simply 50 multiplied by what? Multiplied by 6 multiplied by 10 electrons. When you calculate this in math, you can just calculate the bases and you're going to maintain the what? The power here. So when you multiply 50 multiplied by 6, you get is 300. So it's equals to 300 multiplied by 10 raised to power 18 electrons. Of course, you can maintain the standard form. Yeah, you can maintain the standard form. So under current, calculating current, it's measured by an ammeter. This is all about current. Now, I want us to look at the next thing, which is the voltage. I want us to look at voltage. Yeah, we're going to look at measuring voltage. Measuring voltage. Measuring voltages. And before we look at measuring voltages, of course, we need to understand what is this voltage. When we talk about voltage, we mean the amount of energy which is given to the charges. The charges cannot just flow without some energy, so they should be given some energy for them to flow. So voltage, when we talk about voltage, we mean the amount of energy given to the charge. And where do we get this energy from? Of course, this energy, we get it from what? From the cells, from the batteries. Of course, for a simple circuit, we should have a cell and a battery. So we get this charge, we get this energy from, energy is provided by what? By the cells and batteries. Cells and batteries. That's where we get this energy from. And what measures this energy? This energy is measured by a voltmeter. So we measure voltage using a voltmeter. So voltage is measured by a voltmeter. Voltage is measured by a voltmeter. And a voltmeter has a symbol, of course. It has a symbol, and this is the symbol for a voltmeter. So for a voltmeter, it has V, and we said for an ammeter, it's capital A. And what are the units of this voltage? What are the units of this voltage? The units of voltage is usually volts. The units of voltage, is volts. And of course, the symbol for volts is capital V. So if you get an answer which is a 3, you simply write 3 volts. There is no need of writing it in full. When just write in physics, even if you use symbols, we understand. Unless you've been asked to get the SI units, that's when you write in full. So we're going to narrow down to calculating voltage, and we're going to compare with the current. Before we continue to calculating voltages, a voltmeter is connected in parallel. Remember we said an ammeter is connected in series, but for a voltmeter it's connected in parallel. When we say parallel, we mean it's across the what? The simple circuit. So a voltmeter is going to be drawn in what? It's going to be connected in parallel. So this is how it's connected. So we have our voltmeter here. This is just a sketch. Of course, for a simple circuit, you must put a what? A switch, all those. Yes. So a voltmeter is always connected across. It's connected in parallel across the what? The bulb. And we usually use our bulb as our component. We use it as a what? Our component. So we're going to narrow down. We're going to narrow down to calculating this voltage. How do we calculate voltage? What is the formula? We've already said the units are in volts. Now, what is the formula of calculating our voltage? So we're going to look at calculation of our voltage and calculating voltage. Calculating voltages. The formula we use to calculate voltage is usually connected in a current multiplied by what? Resistance. We calculate voltage by using current multiplied by resistance. And as we move maybe to in our next episode, you're going to understand what R is. But meanwhile, R is resistance because we're going to use it here. So R is resistance. And most of the time resistance is measured in ohms. So resistance is measured in what? In ohms. In ohms. For the purpose of identifying resistance in our question so that we can calculate voltage, so I'll have to tell you this first before we reach at that point. So, and ohms, the symbol for ohms is this one. This is the symbol for ohms. This is a symbol for ohms. And for example, we have resistance of 3 is going to be 3 ohms. We're going to narrow down to calculating this voltage, and we're going to use some examples here. Okay. So calculating voltage, of course, we need current and resistance. Now, we said this voltage is energy. Now, before we even go to calculating voltage, what is this? How can we get this energy? Sorry for skipping that part here. So we'll have to go to that part first. Yes. So how do we get this energy? How do we calculate this energy? Yes. So our energy is calculated by quantity of charge multiplied by what? By volts. Voltage. So and of course from the previous episodes, I'm sure we might have covered that. So energy is always measured in joules. Energy is measured in joules. Energy is measured in joules. So energy is measured in what? In joules. And we're going to use examples here. So remember we had said quantity of charge is equals to current multiplied by what? By time. And we have said energy is calculated by quantity of charge multiplied by voltage. So when we simplify energy and we replace, we do what? We substitute our quantity of charge by current multiplied by time. So energy is going to be calculated by current multiplied by time multiplied by voltage. So you can find a question whereby you are being given current, time, voltage without them telling you that they're giving you quantity of charge. So I'm going to narrow down to examples. So example one here. Example 1. Example 1. The voltage across a light bulb. So the voltage across a light bulb is 2 volts. Voltage across a light bulb is 2 volts. Calculate the electrical energy. Calculate the electrical energy. Calculate the electrical energy transferred when 50 coulombs of charge transferred when 50 coulomb of charge passes through it. So we are being asked to get here energy. Calculate the electrical energy. And we have said energy is calculated by what? By QV. Or rather, current multiplied by time multiplied by what? Voltage. And so what's our voltage here? Our voltage is 2. And what about our quantity of charge? Is 50 coulombs. So how are we going to get our energy here? Our energy is going to be calculated by our quantity of charge, which is 50, multiplied by what? By voltage, which is 2. You find 100 what? Sorry, 100 joules. So our answer is equals to 100 what? 100 joules. Of course, we have said the units of quantity of we have said the units is always in joules. Yes, so 100 joules. And we have seen how to calculate energy, and we have also seen how to calculate quantity of what? Of charge. And the next thing I want us to finish with here, is what is this? The difference between series and parallel. The difference between series and what? And parallel connection. So series and parallel circuits. Yeah, so what is the difference? You know, I've been talking about series and parallel circuits all over the episode. But now, what is this difference? And in series circuits, we don't have branches. The current does not flow in branches and junctions. The current only follows one path. So here, no branches or junctions, i.e. current follows what? It follows one path. And of course, I'm going to show you in a drawing. So this is our circuit, our series connection. And of course, it has a switch here. There is a switch here. You know, for a complete circuit, we must include a switch. And we have our bulb here. We have the second bulb here. We're going to have our switch, another switch here. We can even have 2 to 3 switches here. Yes, we can have 2 to 3 switches here. We can have even more than 3 switches there. Yes, this way. Let's just have 2. So you can look at, we have bulb A and bulb B. You're going to realize here the bulbs are connected it's connected in series. And of course, this is the flow of current. We call it convectional flow. Yes, so look here. We have how many switches do we have? We have around 2 switches, and we have 2 bulbs which are connected in series. You're going to realize here the bulbs are going to have same current. If bulb A is going to have 2 amperes, bulb B is going to have also 2 amperes, because the same current which is flowing through this side is the same current which is going to flow throughout this circuit connection. And we said the path, there is only one path through which this current flows. Yeah, so we're going to draw with a parallel. I'm winding up, so I will just draw the parallel one very fast. Yeah, the parallel. And in parallel, we have said that the circuit, the current is going to follow junctions, multiple junctions or branches. So here we have branches or junctions through which current flows. Yeah, so here current is going to follow multiple junctions. Of course, we have our we have our cell here. This is a cell, by the way. This is a cell. So we're going to have the first junction here. The first junction here. Of course, it must have its own switch. The first junction here. We're going to have the second junction. It has its own switch here. We can even have the third junction. And of course, it definitely has its own switch. Why am I even insisting that it has its own switch? Because these bulbs are connected in parallel and they're going to be put off and on independently without interfering with any other, each other's bulb. And so here we have bulb A, B, C. We're going to realize that each and every bulb is going to have its own current. This can have 2 amperes, this can even have 3 amperes, and this can have 1.5 amperes. Yeah, so this is the difference between series and parallel connection. So just a recap of what we have seen here. Of course, we have looked at current, and we have realized that the ammeter is connected in what? In series. We said a voltmeter is the one which is connected in what? In parallel. And just to remind you, a voltmeter is connected in parallel because it has some higher resistance to electricity than than our ammeter. Of course, I gave you a formula for calculating voltage. Voltage is equal to what? IR. We've not used this formula. We're going to use it in our next episode, which we are going to have very soon. And again, another thing, don't forget, this one is a bulb. This one is a bulb. We're going to look at more of them, and in our next episode, we're going to look also at our diode here. This is how a diode looks like. And I told you we're also going to look at what? At resistance. We're also going to look at resistance and many others. Thank you for joining us today. Always welcome to our Horizon TV, and we're going to enjoy so many things from Andalusia Academy. Yeah, so for today, that will be all, and I hope you're going to join us next time. So thank you so much.
Are you looking for a school that nurtures your child's academic, spiritual, and personal growth? Andalusia Academy International School, where your child's future is our priority. We offer comprehensive education levels: kindergarten, Pearson I Primary Certificate, secondary, and Pearson IGCSE Certificate.
We are a school that emphasizes in the Deen and Dunya. It's integrated in that on the side of Islamic studies, we have Quran, we have Hadith, we have Arabic. And then, of course, in the secular side, we have all the subjects.
We focus on student-centered learning, where we engage our students in different levels. Other than that, we have very innovative teachers who help to cultivate creative thinking, problem solving, which are very, very key skills in learners, not only in school, but also for their future.
Hello everyone, my name is Aisha Muhammad and I'm a student under Andalusia International School. I've been here for the past 5 years and I'm in year 11 right now, and my experience in this school so far has been amazing.
Admissions are available. Visit us today. We are located in Nairobi, South Sea, Andalusia Academy International School, where your child's future is our priority.